Hello, in our last video to learn in this chapter is related to the shape of distribution. I understand that at the beginning of the last chapter we already learned we can look at a histogram to determine if the distribution is skewed right or left. And also at the beginning of this chapter we look at the relative position of the media and the mean also can tell us information. However, here I want to just introducing a statistic and directly telling you whether it's a skewed right, left, and highly skewed or moderately skewed. So this statistic is called skewness. Okay, so as you can see, the statistic we use to measure is called the skewness coefficient. Please do not spend time to memorize this formula. We will never use it, and we don't calculate by hand. If we're going to calculate skewness, we're going to use Excel. Okay, so one thing I want to call out on this formula, and the reason I want to still show you here is because it's really different from our variance, right? So we have xi minus x bar. We saw this kind of calculation in the variance, but here instead of 2 we have 3. So it's a difference the almost and then divide by this. So here's the more like standardize your x, right? And instead of powered by 2 we powered by 3. That means for the skewness it's different from variance, that we are able to have the negative and the positive skewness. Okay, why I'm emphasizing this? Because based on the skewness net sign, we are able to identify whether they are positive skewed or right skewed or left skewed. Okay, so look at this equivalency between the shape distribution and the value of the skewness. Okay, so if the skewness is positive, we will have right skew. So thinking about the tail stretched to the right, we call skew right, and during that for that scenario, our skewness also going to be positive. When we skew left, our skewness going to be a negative value. Our tail stretched to the left, which is the negative direction. So when the skewness is very close to 0 or almost equal to 0, so that when we are having a normal distribution, that is considered as a symmetric. Okay, so one thing is missing from this diagram is the strength. So I want you to add in 2 more dots here. One is 1, the other one is -1. Okay, so if your skewness is between -1 and then the +1, we consider as moderate. Okay, so if your skewness is larger than 1 or smaller than -1, we call it highly skewed. So give you example here. Let's see the skewness equal to 0.75. Okay. If your skewness equal to 0.75, first of all, it's a positive, and then so it's a skew right. Second is between -1 to +1, so that would be the moderate skew right, moderately skewed right. Okay, how about -1.75? So it's a negative, so this therefore skew left. And also it's in the -1 to negative infinite range. So therefore this will become the highly, right? Called the highly skewed left. Okay, so the interpretation here, like this scale I built for you, are kind of similar as our correlation coefficient. Remember the cutoff point, right? Remember those cutoff point allow you to learn how to interpret in the skewness. And like I said, later we're going to look at Excel. I'm going to show you how to use Excel to calculate the skewness. And I just want to call it out for the skewness. If you use Excel, you just type skew and then select the whole column of the data, and you are able to calculate the skewness. And the alternative skewness is called the Pearson 2 skewness coefficient. And we just need to do some modification, where M is the sample median, and you are using the mean of the sample minus the median times 3 and divided by standard deviation. So this intuitively attractive statistic too easy to calculate using just the 3 common descriptive statistic. It expresses the difference between the mean and the median in terms of the standard deviation. Remember, we're talking about how to, based on the mean and median, identify the shape distribution. So basically this Pearson 2 skewness coefficient leveraging that idea. Okay, so by default, skewness is the skewness we just showing you. Use a more complicated formula. But if the question did ask you what is the Pearson skewness coefficient, then you're going to use the formula here. Okay, and then now I can move on to the computer skill to learn how to use this. Use the Excel to calculate the skewness directly. And so good luck for your learning. So that's the end of this chapter.